Good day, everyone. Today, we're going to explore one of the most important topics in trigonometry, the verifying trigonometric identities. So, this identity is an equation that is true for all values of the variable where both sides are defined. And we will cover fundamental identities, sum and difference formulas, double angle, power reducing, and half angle formula. And now, let's start discussing the fundamental identities. So fundamental identities are the basic relationships between trigonometric functions, and this includes reciprocal identities, quotient identities, Pythagorean identities, co-function identities, and even and odd function. They are essential tools in simplifying and verifying expressions. Example number 1. Simplify the expression. We have here the example number 1. Simplify the expression sine of negative x times cosine of negative x times cosecant of negative x. First, we apply the odd-even identities. Next is, we use the reciprocal identity of cosecant x. Then cancel out the same. Therefore, the simplified of this expression is cosine x.
Example number 2. Simplify the expression.
Simplify the expression cotangent of t plus tangent of t over secant of negative t. To solve this problem, we begin with even identity of the second function. Then, apply quotient identity where cotangent of t is equals to cosine of t over sine of t and tangent of t is equals to sine of t over cosine of t. After that, we combine the fractions and then use Pythagorean identity and then multiply by reciprocal of secant of t. Then apply the reciprocal identity. Therefore, we can conclude that cotangent of t plus tangent of t over secant of negative t is equals to cosecant of t.
Example number 3. Verifying an identity.
Verify the identity sine squared of negative theta minus cosine squared of negative theta over sine of theta minus cosine of negative theta equal to cosine of theta minus sine of theta. So to solve this, we begin with the left side and we apply the odd-even identities. And after that, we apply the difference of squares. And then, we factor and simplify. Therefore, the identity is verified.
Example 4. Verify the identity.
Tan of theta is equal to sine of theta times secant of theta. To verify this identity, we begin with the right side. Now, we use the reciprocal identity of secant. And then, we simplify. Therefore, this identity is verified.
Example number 5. Verify the identity.
We begin with the right side of the equation, and let us find its common denominator. After that, we use the FOL method to multiply. Then, simplify. After simplifying, we apply the difference of squares. Then, use Pythagorean identity. Next is to factor, and lastly is to use identities. Therefore, the identity is verified.
Now let's discuss about the sum and difference formulas. So this is used for sine alpha plus minus beta, cosine alpha plus minus beta, and tangent alpha plus minus beta. So these are the sum difference formula. First is the sum and difference formulas for cosines and sines. Next is sum and difference formulas for tangents. These formulas help evaluate trigonometric functions involving sum or difference of angles.
Go.
Example 1. Find the exact value of the following angle using cosine and sine function. Theta is equal to 30 degrees. So, we're gonna use the difference formula for sine. Next, we apply the sine alpha minus beta is equal to sine alpha times cos beta minus cosine alpha minus sine beta. Then, we substitute the exact value. Therefore, sine 30 degree is equal to 1/2. Next, we're gonna use the difference formula for cosine. We're gonna use the cosine alpha minus beta equals to cosine alpha times cosine beta minus sine alpha times sine beta. And then, we substitute the exact value. And then, we simplify. So, the exact value of cosine 30 degree is equal to 3 square root of 3 over 2.
Example number 2. Find the exact value of the following angle using sine and cosine function.
The first thing that we should do is to find the exact value of the angle using the sine function. So in here, we use the sum formula for the sine. And then, we substitute the exact value. After that, to get the final answer, we simplify the equation. Therefore, we can conclude that sine of 135 degrees is equals to square root of 2 over 2. Another one is to find the exact value of the angle using the cosine function. In here, we use the sum formula for the cosine function. And then, we substitute the exact value. To get the final answer, we simplify the equation. Therefore, we can conclude that cosine of 135 degrees is equals to negative square root of 2 over 2.
Example number 3. Verify the identity. Cosine times pi over 2 minus theta equals sine theta. So, to start, we begin with the left side. And then substitute the exact value. So, therefore, cosine times pi over 2 minus theta is equal to sine theta.
Example number 4. Verifying an identity.
Sine times alpha minus beta over cosine alpha times cosine beta is equal to tangent alpha minus tangent beta. To solve this, we begin with the left side. So first, we use the difference formula for sine. And then, we rewrite the expression by separating each term in numerator. And after that, we simplify. Therefore, the identity is verified.
Example number 5. Verify the identity.
We begin with the left side. Then we use difference formula for sign. Then we substitute the exact values. Then simplify. Therefore, the identity is verified.
So now let's proceed to the next topic, double angle formulas. Double angle formulas expressed in trigonometric functions of 2 theta. For any real number theta, this is the formula for sine 2 theta, and this is the cosine 2 theta and tangent 2 theta. And here we have the three forms of cosine. We choose the form depending on what is given in the problem.
Example number 1. Use double angle formulas to find the exact values.
We begin with a sketch that illustrates the problem. Since sine theta is equal to y over r, this means that y is equal to 15 and r is equal to 17. By using these values, we can solve for x. Because the angle lies in quadrant 2, x is negative. In solving for x, we will use the formula x squared plus y squared is equal to r squared. Now, let's substitute the values of y and r. Then, solve for the square of 15 and square of 17. Then, subtract 225 from both sides. After that, we can solve for the square root of 64. So, our x is equal to negative 8. Now that we have our values of x, y, and r, we can use this to find the required values. Since cosine theta is equal to x over r, this means that our cosine theta is negative 8 over 17. Now we can use this to find the sine to theta. By using the double angle formula, sine to theta is equal to 2 sine theta times cosine theta. Then substitute the values of sine theta and cosine theta. So, this is the value of our sine 2 theta. Then now, we can solve for our cosine 2 theta by using also the double angle formula for cosine 2 theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. We will just substitute our values of cosine theta and sine theta. So, this is our cosine 2 theta.
Example number 2. Use the double angle formula for tangent to find an exact value.
So we must find the exact value of this expression. The given expression here is the right side of the formula for tangent to theta, with theta is equals to 30 degrees. So the expression to tangent 30 degrees over 1 minus tangent squared 30 degrees is equals to tangent of 2 times 30 degrees, where it equals to tangent of 60 degrees. So the value of tangent of 60 degrees is square root of 3.
Example number 3. Verifying identities.
We have here the example number 3. Verify these identities. First example, sine 2 theta equals 2 tangent theta over 1 plus tangent squared theta. So we start with the right hand side of the identity. So this is from the Pythagorean identity. Next is Reciprocal of quotient identities. We simplify. Then, from the double angle identity for sine. Therefore, sine 2 theta is equal to 2 tangent theta over 1 plus tangent squared theta. Number 2, tangent 2 theta equals 2 over cotangent theta minus tangent theta. And in this case, we begin with the left side of the equation. We use the double angle identity. And then we simplify. And then use the reciprocal identity for 1 over tangent theta. So, therefore, tangent 2 theta is equal to 2 over cotangent theta minus tangent theta.
Example 4. Use the double angle formula to rewrite the expression. For sine x times cosine x. First, we use the double angle formula and then we can rewrite the given expression as so we factor it and substitute.
Example number 5. Expressing sine 3x as sine x.
Express sine of 3x in terms of sine of x. So to solve this, first is we rewrite the sine 3x as sine times 2x plus x. And then, we use the sine sum formula and the double angle. And then we simplify by multiplying it. And then, after that, we apply the Pythagorean identity. Next is we distribute or multiply it. And lastly, we combine the like terms. So, the expression of sine 3x in terms of sine x is equal to 3 sine x minus 4 sine cube x.
So now let us proceed to the next topic, which is the power-reducing formula. Power-reducing formula are derived from the cosine double angle formulas to express squared trigonometric function of sine squared x, cosine squared x, and tangent squared x. So these are the primary formulas for power-reducing. First is sine squared theta is equals to 1 minus cosine of 2 theta over 2. Then cosine squared theta is equals to 1 plus cosine of 2 theta over 2. Then for tangent, tangent squared theta is equals to 1 minus cosine 2 theta over 1 plus cosine of 2 theta.
Example number 1. Proving power reduction formula.
Prove the power reducing formula using the double angle. So to prove the power reducing formula for sine, cosine, and tangent, we use the double angle. For sine, we use the double angle formula. Subtract cosine 2 theta from each side and add sine squared of theta to each side. And then, we divide each side by number 2. For cosine theta, we also use the double angle formula. We add 1 to each side and then we divide each side by 2. Therefore, we prove the sine and cosine formula using the double angle.
Example number 2. Reducing the power of a trigonometric function.
Reducing the power of trigonometric function. To solve this problem, we begin with applying the power reduction formulas and multiply them. And then applying again the power reduction identity to cosine squared 2 theta. In power reduction formula, we replace theta with 2 theta. Applying the power reduction identities twice, the product sine squared theta cosine squared theta is rewritten as the difference of 1/8 minus 1/8 cosine 4 theta.
Example number 3. Writing an equivalent expression.
So, in this problem, to write an equivalent expression for sine to the power of 4x, we start to apply first the power reduction and expand the squared binomial. We apply the power reducing formula for cosine where theta equals 2x. And then apply the power reduction formula, substitute, and combine constant terms.
Example number 4. Prove the identity. Tangent 2x is equal to 2 tangent x over 1 minus tangent squared x. So, tangent 2x, we're gonna use the tangent addition formula. After that, we simplify. Therefore, the identity is proven to be true. Example number 5. Writing an equivalent expression.
This formula is the derived form of the double angle formula cosine 2 theta is equal to 2 cosine squared theta minus 1. Then, let's add 1 to both sides. After that, we divide both sides by 2. Therefore, 1 plus cosine 2x over 2 is the equivalent expression for cosine squared x with no powers greater than 1.
So now, let's move on to the next topic, which is the half-angle identities. So half-angle identities are trigonometric formulas used to find the exact sine, cosine, or tangent of an angle that is half of a known angle, derived from double angle formulas. So these are the formulas of the half-angle identities. So the plus and plus minus symbol here in each formula does not mean that there are two possible values for each function. Instead, the plus minus indicates that you must determine the side of the trigonometric function plus or minus based on the quadrant in which the half angle alpha over 2 lies. Example number 1. Finding the exact value using the half-angle formula.
Sine of 15 degrees. To find the exact value of this expression, we use the half-angle formula. To use this half-angle formula, we must find its angle alpha such that alpha over 2 is equals to 15 degrees. Since 15 degrees is in the first quadrant, where the sine function is positive, we use the positive square root. The exact value of sine of 30 degrees is square root of 3 over 2. After that, we simplify the expression. Therefore, the exact value of sine of 15 degrees is equals to square root of 2 minus square root of 3 over 2.
Example number 2. Verifying other trigonometric function using half-angle formula.
Verify the identity sine 2 theta is equals to 2 tan theta over 1 plus tan squared theta. So to solve this, we start at the right side. First is we apply the Pythagorean identities. And then we express tan theta and secant theta in terms of its quotient identity and reciprocal identity. And then we simplify. And then we apply the double angle formula. So therefore, the identity sine 2 theta is equals to 2 tan theta over 1 plus tan squared theta is verified.
Example number 3. Verify the identity.
So this problem, to verify the identity, we start with the left-hand side. First, identify the half-angle formula of each terms. And then, square both formula to remove the radical sign. After that, we combine and simplify. So therefore, we work with the left side and arrive at the right side 1. Thus, the identity is verified.
Example number 4. Simplifying trigonometric expression using half-angle formula. First, simplifying the trigonometric expression to a more recognizable formula. So, we're gonna use power reduction formula in the numerator. Then, we're gonna let theta be pi x over 2, then distribute it. Now, we're gonna cancel the common terms. And now, we're gonna apply the quotient identity. Example number 5. Verify the identity.
Let us start with the left-hand side. Then, use the reciprocal identity for cosine. Then, we simplify the numerator by finding its common denominator. Then, multiply by 1/2. Therefore, the identity is verified.
Finally, we learn how to verify identities using different formulas. Remember, in verifying, start with the complicated side, apply identities, and simplify until both sides match.